So we'll be talking about definitions and postulates for this system called geometry. There'll be a lot of definitions and explanations of postulates in this section that you'll actually just use as true when we get into actually doing some geometry problem solving. But geometry is a mathematical system, just like algebra is a mathematical system, or calculus is a mathematical system, statistics. So, in order for something to be a mathematical system, there are some building blocks. First of all, there are some undefined terms, which are point, line, and plane for geometry. And then once you have these terms, you can come up with additional terms based on points, lines, and planes. So then you'll have undefined terms and defined terms, which are called definitions. Then once you have some definitions, then you can come up with properties. Properties are assumed to be true, and properties will be axioms or postulates. So let's take a look at what this system looks like. So here are the building blocks for the system. Your basic vocabulary will be your undefined terms, which is what is a point, a line, and a plane, and then some defined terms. So once we have some definitions, once we have some vocabulary that we can work with, then we'll add axioms and postulates. They are always assumed true, and above axiom and postulates would be considered theorems. And in this section, we'll get to actually our first theorem. So we're going to have to come up with some definitions, and a good definition has 4 parts. What is a good definition? It has to have 4 characteristics. It can only refer to undefined or defined terms previously defined in the system. Let me just give you an example. They actually have a very good example here. Here is the definition of an isosceles triangle. So an isosceles triangle is a triangle that has 2 congruent sides. And the 4 parts of a good definition are, first of all, what's being defined? Isosceles triangle. So an isosceles triangle, that's what we're defining. What category does isosceles triangle fit into? So its larger category is it's a triangle. An isosceles triangle is a triangle. And then the last part of the definition is what distinguishes an isosceles triangle from other triangles? That is, what is its distinguishing characteristic? What would define it as an isosceles triangle? And in this case, it would be that it has 2 congruent sides. So a good definition has to have what's being defined, what category it falls into, and what makes it unique. And the last point is critical. The definition has to be reversible. So, if an isosceles triangle, if a triangle is isosceles, then it has 2 congruent sides. We should be able to reverse that and say if a triangle has 2 congruent sides, then it is an isosceles triangle. So to be a good definition, it has to be able to be reversed. And in this particular case, it can. So here are once again, down at the bottom, the characteristics of a good definition. So when you're talking about reversing a definition, you might use the phrase if and only if. And in some math books, you'll see that as IFF, if and only if. So 2 angles are congruent, then they have equal measures. If 2 angles have equal measures, then they are congruent. That's a reversible definition, we could say two angles are congruent if and only if they have equal measure. So rather than making it two statements that's reversible, you include the phrase if and only if in the definition. So let's start with some postulates now. A postulate is a statement that is assumed to be true. In other words, you can use it when you're doing logical reasoning. It can assume to be true. It's assumed to be a true statement. And so here's our first postulate through two distinct points. There is exactly one line. So if I have the point L and the point T, I can only draw one line, one straight line through those points. This also implies that there's a unique line segment that's defined as its endpoints. So if I have point A and point B, that is going to be called line segment AB. It could also be called line segment BA, because line does not have a direction. We have no concept of it's going from A to B or from B to A. It's just the line between, connecting those 2 points, those 2 end points. So let's do a little practice here. Here's point A. How many lines can be drawn through point A? Well, here's 1, here's 2, here's 3, here's 4. So can you see that through a single point, there are an infinite number of lines? There are an infinite number of lines that can be drawn through a single point. But if I'm looking at the points A and B, there is only one line that can be drawn through A and B. And here, if I have point A, B, and C, is there a line that can go through A, B, and C at the same time? In other words, are A, B, and C collinear? No, they are not. There is no line that can go through those 3 points. We would say those 3 points are not collinear. And so by now I've already introduced a lot of this to you, but this is where it's being presented formally in the textbook. The symbol for a line segment AB is going to be named by its endpoints, and it's going to have the line segment bar above it. If you do not have the bar above the endpoints, that means the length of AB. So as you look here, this is the line that goes through the points AB. This is the segment that has the endpoints A and B. And this is the length of AB. That's going to be a number, 2 inches, 5 feet, whatever the length is. So we've used a ruler to measure the lengths of a line segment. The length can be called AB, or it can be called BA. The order of the endpoints is not important. However, the length must be a unique positive number. So there are no negative lengths. And a line segment cannot have 2 different lengths. Okay, pardon me. A line segment can't be 3 inches and 5 inches at the same time. And a line segment cannot be negative 2 inches either.